If you've ever taken an introductory physics course, you know that physics is more than just plugging in numbers and memorizing formulas. Oftentimes on physics exams and introductory physics courses, you're going to be given something that you've never seen before. And you're going to have to reason from first principles what you do know about the physical reality of what's going on, and then you're going to have to reason from there to figure out how to solve the problem. And something that you've never seen before. So it's a lot different than other classes in that way that you can't just memorize a formula and then plug it in and then you get it right, but you don't actually know what's going on. You have to know what's going on in most courses. So in this video, I'm going to be teaching you guys how to think in physics and how to think from a physics perspective and how to get better grades in physics. I'm no expert, I'm no PhD student, but over the past year, I've gotten better at physics, I've gotten better at math, and I never considered myself to be good at these things. I never considered myself to be good at math, but through practice and through the right techniques, I got better at these things. I'm a second-year engineering student, and I'm going to be teaching you guys some of the tactics that I've used to get better at physics. All right, so starting off with the first tip that I have for you guys. You guys are probably not going to like this one, but to master the core concepts in physics, you have to learn the derivations of each problem. You don't have to memorize every single derivation, but I highly recommend it. Studying the derivations of each formula, make sure that you understand each step of how this problem or this equation comes about, is going to guarantee that you have more understanding of how this equation works. You're going to have more of a deep understanding of what's going on behind this formula rather than just memorizing it. Because every equation tells some sort of story, but a lot of physics students just memorize the formula and they don't actually know what's going on. So when you're given a problem that you've never seen before, you're not going to be able to know how to solve it because, well, you know, if it's worded slightly different or it looks a little bit different than what you studied, then you're not going to know what to do with it. But if you know how to think about this problem, because you know what actually is going on behind the equation, you're much more likely to be able to solve the problem. For example, F equals ma. A lot of students just memorize this formula, but they don't actually understand the actual story that this formula tells, which is that every single time you have something that accelerates, you have a force that is acting on it. Maybe that's a bad example because, you know, it's kind of a lower level formula. A lot of students might understand that. But maybe something given like V equals IR, a lot of students just memorize this one. I, for example, just in the beginning of learning this, I just memorized this one. And, but I really didn't understand what was going on, which is that I didn't understand the story that this formula told, which is that the amount of push required is directly proportional to how hard it is to move a charge and how much charge you're trying to move. So you have to tell a story, you have to take the formula, and you have to be able to tell a story about it, not just memorize it. And also on top of that, learn how to derive the formulas. If you learn how to derive the formulas, you're going to get a much deeper understanding of how to solve every single problem that you've never seen before, and you're going to get a much deeper understanding of what the formula actually means. And you're just going to have more tools in your toolkit when it comes to things that you've never seen before, things that you've never thought about before. And thinking in a physics perspective, if you know how to derive each formula. Second tip I have for you guys is to just start asking questions about each thing that you learn in physics class. For example, you learn something new, you just often write it down, whatever, you memorize the formula, maybe you do some homework on it, and that's that. If you start to ask questions, you start to imagine extreme scenarios with what you're learning. You start to apply the knowledge that you're learning to your own life, and you start to think about what will happen if this, what will happen if that. You start to, you know, get imaginative with what you're learning and get creative with what you're learning, and push those examples to the extreme. You're going to have a much deeper intuition once you have these questions answered, because it's like you can learn something, but you probably have a million questions about it, but you never pursue those questions, because whatever the professor just tells you, this is true and this is why this is true, and you don't question that. But if you actually really start to question these things, then you're going to get a much deeper understanding way faster, because, well, if you just take what the professor says as true, oftentimes that works. But throughout your career, and if you're trying to become an engineer or a physicist or whatever it is you're trying to do, if you have these gaps in knowledge, you don't actually know what's going on, you're going to run into trouble later. So you want to develop a deep fundamental understanding in the basics by asking these questions, and pursuing your curiosity in these things. And if you don't find any natural curiosity, well, then you can just force it. If you learn something new, you have to stare at that thing and you have to say, what is it that I find interesting about this? Even if it's the most boring thing possible, you have to find something interesting about this. And you can use AI, you can use a bunch of other tools to make this thing interesting and make yourself curious about it. What happens if this? What happens if that? Apply it to things that would actually happen in your real life. Apply it to things that you're already interested in, and apply that curiosity and ask questions that you yourself think of. And then you're going to develop a much deeper intuition. And on top of that, you're going to develop more neural connections in your brain, because you're applying and you're connecting those concepts to things that you already think about and things that are already in your life. So, just ask questions about these things. Become curious about what can happen if this, what can happen if that. And you're going to develop a more intuitive sense of physics, and you're going to just enjoy it more as well. It's going to become more fun if you ask these types of extreme questions and you know the extreme examples, because, well, it turns into something that's like, oh, you're just memorizing this formula, to maybe something that, well, you see something happen in your daily life and you can explain it to somebody. You can explain, this is why this works, and it becomes a lot more fun in that sense. All right, number 3, I'm going to get into more nitty-gritty physics and study tips. Just create a personalized study routine. So personally, I love to study in the morning. This is when I have the most energy. I love to wake up right away and just get straight to work, get straight to my hardest concepts, because that's when my brain is the most at its full capacity, right? Because if you get a good night's sleep, you're going to have more mental energy. If you have a better diet, you're going to have more mental energy. So just realize when you have the most mental energy, and then make sure that you study at that time. Like I said, I love to wake up in the morning and I do like 2 hours of deep study, 2 hours of my hardest concepts, which right now is physics. So, and I also use this morning time to learn new concepts, because that's the hardest thing for me to do right now, is learn new concepts. If I'm just doing practice, well, then I can afford maybe to do that later in the day, when I'm at the library later in the day after classes, when I have less mental energy, because I'm just reviewing, right? But when I'm learning new concepts, I'm doing active recall, I'm doing new things. I love to do these things in the morning with a cup of coffee, fasted. That's just me personally. But again, use your own knowledge of your habits and your routine to create your own personalized study routine and stick with it. And of course, you can make tweaks as you go, but create your personalized study routine. You do not have to do 2 hours. You can do 20 minutes, 45 minutes, 90-minute periods. And through these periods, you want to be alternating through theory and practice. So for example, if you're gonna do 45 minutes of deep study, you want to take whatever 10-15 minutes to review what you're learning right now, and then you want to spend the rest of that time to do practice problems on that thing. You don't want to just spend the whole time reviewing notes, and you don't want to just spend the whole time, doing practice problems, because if it's too hard, then, well, you're going to get burnt out. But if you review and then you do practice problems, alternate through theory and practice, then you're going to retain that information much faster, and you're going to directly apply the information that you just learned. This is such a key and core idea in physics, especially. If you learn something, you can think you know it, but then once you have a homework problem and you don't know how to solve it, well, then you've learned nothing. You have learned something, but it doesn't matter in physics, because if you can't solve the problems on the exams, then you're not going to pass the class. So make it a priority after learning something in class or learning something on your own to try to immediately do some sort of practice problem or active recall on this thing, so that you can reinforce that information in your brain in a way that you're applying it to some sort of problem rather than just memorizing what's going on. Because again, physics is a lot different than other classes. You need to learn how to apply the information that you've learned to look at a problem and solve it. Because you can know everything that's happening, but if you don't know how to solve the problem, if you don't know how to do the math, well, then you're still cooked. So yeah, alternate through theory and practice. And then at the end of the week, do a general review of what you've studied and identify what is still unclear. Okay, so for me, I like to do this thing called the blurting method. At the end of the week, I write down what I've gone through this week, whatever's been covered in the lecture, and I just do the blurting method for about 30 minutes, which is just, you take a whiteboard, you take a notepad, and you write down everything that you think you know. Everything, I mean everything. And this takes about 30 minutes, but you write down everything you know, no notes, of course. This is just, you're pulling information out your brain. And then the key with this is you have to go in afterwards and you have to look at what you've wrote down, and you have to figure out what is still unclear, what still doesn't make sense. Because if you're blurting the things out, oftentimes you're going to realize, okay, well, I thought I understood this, but I don't really understand this, because, well, I'm trying to explain it on paper right now, and it's not making much sense. So perfect. Now you have to go back and review that concept, go do some more practice problems on that concept. You've identified what you don't, yet fully understand, and also you have identified what you do understand, so you can have an accurate idea of where you stand in the course. So yeah, just at the end of the week, do a general review of what you've studied and identify what is still unclear. Also, before exams, what I like to do is I list out, usually you're given an equation sheet, and you want to take that equation sheet and you want to go and you want to explain what each equation means. I mean, this is probably something that you've done before, but it's just another tip that I'm giving you. You want to know what each equation means, okay? So the next tip that I have for you guys is, do not skip concepts, because concepts stack on each other. If you don't understand something about Gauss's law, well, then you're not going to understand Maxwell's equations. And this happens throughout your career as in an engineering major or whatever it is that you do. You're not going to be able to skip certain pieces, because chances are that your whole idea of what's going on is going to fall apart if you skip some sort of main concept. So do not skip pieces. Last tip I have for you guys is just to practice. I know I already said this, but The way that you learn in physics is not through memorization. You have to practice problems, and you have to spam practice problems, and you have to do things that you've never seen before, and you have to sit there and you have to struggle with it, and you have to think from first principles. And let me tell you that physics is hard, but the dopamine hit and the fulfillment that you get from taking a problem that you've never seen before, and you've worked hard at studying this concept, and you take a problem that you've never seen before, and you sit there and you are, you're baffled, you don't know what to do with it. But the dopamine rush that comes from finally thinking, oh, that's what I should do, and getting the problem right is so amazing. It feels so good to get something right like that after so much hard work. I'm just saying this so that you can push through those moments, and that's when the real learning happens, is when it feels really hard. Because on the exams, you're probably gonna get some sort of problem that you've never seen before, and it's gonna feel really hard. But if you have the confidence that you've done this before, you're gonna stay a lot more calm, and you're gonna be able to solve the problem. So yeah, that's all I have for you guys for studying physics and getting better at physics. Yeah, peace out, guys.